design and manufacture for Howard Dump Trailer today. I'm Brian Schumacher.
Terry Meyer. Nathan Myers. Adam Shura. Victor Code.
And we work in conjunction with Worthington Trailers and Excel Hydraulics and our advisor, Dr. Fred Miller.
So the original problem state that we got posed with was that we had a customer come up to us and asked us to build a trailer that could pick up 3 tons of coal, lift it 8 feet in the air, and be able to dump it over his fence so he wouldn't have to haul by wheelbarrow into his basement anymore.
So last semester, our main objective was partnering with Worthington Trailers because they agreed to sponsor our project. We also designed the top-level dump body and constructed the base frame, which is a stock Worthington product. And that model there, you can see, is circa October of last year. So now you can see our current model and our fully constructed device. And the major components have stayed the same throughout the entire project, which are the dump body, scissor lift, subframes, electronics, and stabilizing outriggers.
So obviously the key component was how we're going to get this thing up in the air. So we decided to go with a scissor mechanism for stability. We ended up building these scissors out of 4x8 aluminum I-beams, 6061, and we plated it at the joints. Basically they're 10 foot long, a single level, built and designed to hold 3 tons. And they have a 5-degree down position, a 40 degree up position, and then they have a lift height of 6.5 feet roughly from the base trailer to the top of the subframe. So here you'll see the joints that we designed, and you'll see the actual model, and you'll see the picture next to it. So what we used was we used 1/4-inch plate on the I-beam to box it so that we had more surface area to put our bushings in. We sleeved them with aluminum, and then we used bronze bushings inside of the aluminum for the hardness. And then we put 1 1/4-inch stress-proof pins in there, which have 100 psi yield strength for the strength of the pins. And then you'll see we have slide feet. Obviously, you have 4 fixed pivots, and you have 4 sliding areas that we call feet. And those sliding feet have UHMW self-lubricating pads on the bottom to help ease the slide instead of rollers. Rollers would have little rocks and stuff done up. So we use pads. There's your CNC build to accept the I-beams on the 1-inch aluminum plate there.
The next major component to the trailer is the dump body. It's a complete custom design. We work with Worthington Trailer. It's easy to do. It's all aluminum construction. Provides a 28% decrease in weight over conventional steel body. It's capable of holding 3 tons of material, 3 cubic yards of material. It features a 3-piece flared aluminum side, and the reason we did that is actually a dual-purpose design. We're looking to adapt this to work in the back of pickup truck beds as well. But for now, the reason that we did that was to prevent material from sticking on the far sides of the trailer and create a side loading situation for the scissor lift, which would prevent potentially tip the scissors over. The weight of the bed is 522 pounds, and it's critical to minimize the dead weight on the top of the scissors. It makes it easier for it to lift. It also features a raised front panel to protect the hydraulics and the rest of the trailer, and it also features a 3-way tailgate. The tailgate splits into 2 pieces and allows you to have a barn door action, a tilt up and a tilt down function. And there's some pictures of the actual bed in relation to the model. On the left is the most recent model. The right is a sample of the door. What you see on the far right is the center hinge for the barn door. The top left of that picture would be the other hinge for the barn door. This is the base frame for the sub. What we did was we had 4-inch I-beams in place for the H section for the cylinder to push off of. We chose that over C-channel over rectangular for strength. And this is a picture of the dump in air. The left picture is from the back of the trailer to show the angle. And the right side is a picture of the pins where the bed actually pivots about the base trailer. What we did was we made a subframe for the dump, and we used an aluminum sleeve and then a 4130 chromoly pin to pivot the bed. And this is a picture of the front board, as I spoke about earlier. It's raised to prevent material from going over the front and damaging the hydraulics and electronics for the front of the trailer. And then the bed side is the right picture, and that shows you the 3-piece construction. In order to get the appropriate profile, we had to use 2 pieces of rectangle tube and then a piece of C-channel in the middle to get the angles correct.
All right, so if you remember from last semester, we were investigating different types of actuators for the scissor lift. First it was block and tackle type pulley system driven by a winch motor. We also looked at power screws. However, the frictional forces and torque requirements for those just proved unfeasible for this project. So we went with a hydraulic system. Basically, the durability, ease of serviceability, and reliability, outweighed any other actuator we could come up with. For the scissor lift, we did the analysis and determined the size of the boards we needed. We used a method called virtual work, which equates the vertical movement of the trailer bed with the different angle movement of the cylinder. As you can see, went through, solved for the force, solved for the bore diameter. It should be noted that it actually calls for two 6-inch bores. We went with 5-inch bores because it only raised the pressure about 20 psi. And we did all our calculations at 1,500, but our system was rated for 3,000. So we accepted that for the price and availability for 5-inch cylinders. For the dump body actuator, we found a position where we wanted to push from, which would give us a 45-degree dump angle. From there, we saw the starting angle of the actuator. On forward, on reverse, and off completely. The system's set up in such a way that you can only do one at a time. You can only raise, and then you can dump. You can't do either one. Then from the scissor solenoid, we have the two 5-inch cylinders run in parallel.
Seeing as this is mainly a mechanical project, the electrical comprised of 2 main systems plus some miscellaneous. The first was a scale feature, which ended up to be design only. As the customer had stated, it didn't add significant value to the trailer. And this
To a horizontal design. Last semester we were going to go with back design. There was not enough room to attach it clearly to the back, so we went back and went and welding it with the picture above. You can see it was welded on the front. If you saw the review side, you can see it welded directly to the back. They are manually operated because making them hydraulic would be way too expensive in the area between $1,500 and $1,800. They have a 20-inch horizontal extension, and the jacks can hold 8,000 pounds and lift 7,000 pounds, which is more than sufficient for our level. So even though we've done this for over a year, we still have some more stuff to actually continue to work. We need to add storage to the subframe, install a full safety mechanism, we have to increase the dump angle. We can try to make the outriggers hydraulic prices right, and we need to design the chute.
All right, we'd like to especially thank Worthington Trailers for not just monetary and material support, but design input and construction help, and Excel Hydraulics for helping us put together our hydraulics package. I'd also like to thank Logue Industries, Team Supply, and various faculty and staff listed. Here's a 2.5-ton load test with wet sand.
We'll take questions during the video at this time.